And once again, I'm here today to talk to you about groundwater level changes, predominantly here in Nebraska. Quick outline, we'll talk briefly about the groundwater and geology of the High Plains Aquifer, both here in Nebraska and a little bit through much of the High Plains Aquifer all through the Great Plains. And then we'll talk a little bit about the groundwater level monitoring program, some of the data we collect, some of our recent groundwater level changes, the recent drought that we've been working our way through, and we'll finish up with some sources of information. It should be quite a bit of time for questions too. So, I don't want the slide to be an insult to your intelligence, but believe it or not, this is one of the bigger misconceptions that I get. What is an aquifer? We hear this term quite a bit. Right out of the geology textbook, it's a body of rock or sediment that contains sufficient saturated permeable material to conduct groundwater to yield significant quantities of water to wells and springs. In other words, it's sediment and rocks that are permeable, so they have pores that can hold water. In this picture, this is a outcrop of Ogallala sandstone. This is at the spillway for Lake McConaughey. And this is a fairly coarse sandstone. So if we were to take a piece of this and look at it under a microscope, we'd see something like this cartoon image over here, where the sand grains are the gray dots, and the pores between those grains, the blue areas, are what holds the water. An aquifer is not an underground lake. There are certainly parts of the world where there are underground caverns. Some of those are full of water. By definition, they don't necessarily count as aquifers. That's not what we have here in Nebraska. Here in our state, our groundwater is held in those pores between grains. Here in Nebraska, we have numerous different aquifers that we use for drinking water and for irrigation. Predominantly today, I'm going to talk about the High Plains Aquifer. That's where most of our water comes from. It's one of the biggest, most well-known aquifers in the state. If you're from the eastern part of the state, you may be getting water from the Dakota Aquifer or from some of the paleo valleys in the southeast part of the state. This column on the left side of the slide has some of the aquifers that we have here in Nebraska. If we look at this in map view, the blue area is the High Plains Aquifer in Nebraska. The brown area on this eastern side of the state here is the Dakota Formation, and some of the pink areas are some of those buried paleo valleys I mentioned. What those are essentially are old river valleys that were filled with sand and gravel. That sand and gravel was subsequently buried by other sediments. It's quite coarse, and today they yield quite a bit of water. Once again, primarily today, I'm going to talk about the High Plains Aquifer. So, the High Plains Aquifer is many times referred to as the Ogallala Aquifer, and it's not quite technically correct. The High Plains Aquifer covers parts of 8 states, blue area in the map down here in the corner, and in those 8 states, there's numerous different geologic units that make up the aquifer. Here in Nebraska, we have the Brule Formation, a relatively fine siltstone out in the Panhandle, along with the Aquifer group, which is a sandstone unit. Through the center of the state, we have the Broadwater Formation, which is a fairly coarse sand or sandstone. And here in the eastern part of the state, we have some Pliocene and Pleistocene aged sands and gravels. Some of those are coarse, they hold quite a bit of water. So there's more to it than just the Ogallala Formation, which indeed does make up a large portion of the High Plains Aquifer. A little bit about the High Plains Aquifer here in Nebraska. So once again, the aquifer covers parts of 8 states, in total about 175,000 square miles. Under our feet here in Nebraska, we've got around 64,600 square miles, which comes out to about 36% of the total area of the High Plains Aquifer is under our feet here in Nebraska. In that 36%, we have 2.040 billion acre feet of water, and that's billion with a B. If you want to put that in gallons, it comes out to this gigantic number. It's a little hard to wrap your head around that to put that in context. The Missouri River at the outflow where it flows, the Platte River where it flows into the Missouri River has an outflow on average somewhere around 8,500 cubic feet per second. At that rate, that would take about 326 years of flow of the Platte River to make up this quantity of water. To put that a little differently, that's about 60% of the volume of the Grand Canyon. If we look at Cherry County alone in Nebraska, this is a saturated thickness map of Nebraska. This is a map that we're currently working on. The brown areas certainly do have saturated thicknesses, they're just not mapped yet. Parts of Cherry County down in the southern border here have 1,000 feet of saturated thickness. So it's 1,000 feet of sediments that are completely saturated with water. In this county alone, somewhere around 287 million acre feet of water. Put that into context, the entire state of Kansas, in the High Plains Aquifer in Kansas has 260 million. So Cherry County has somewhere around 17 million acre feet more water than what's held in the High Plains Aquifer in Kansas, and nearly as much as what's held in Texas. So shortly after World War II, groundwater irrigation began to expand on the High Plains. The technology was developed both for drilling and both in pumping, and we moved from what was predominantly dryland farming back in the 1930s. If you look at this upper image, this is outside of O'Neill, Nebraska. O'Neill is down in this corner. We see smaller plots growing mainly grains, things that can grow in the drier climate of Nebraska, things like wheat, things like sorghum. Following World War II, after the expansion of irrigation, we see the same aerial photo. Here's O'Neill again, and we see mainly center pivot irrigations growing things like corn and soybeans. Back in 1939, there were very few active irrigation wells in Nebraska. Last I checked for today, we're somewhere around 95,000. We've seen a similar expansion all across the High Plains Aquifer. Some of the more arid states, particularly places like southern Kansas, parts of Texas, Oklahoma, have seen groundwater level declines of more than 150 feet. We're certainly not immune to those declines here in Nebraska. I'll talk a little bit more about that in a little bit. But some of these areas in some of those southern states, particularly down here in parts of Texas, today only have in the range of 50 to 200 feet of saturated thickness left. So essentially, this is kind of an ominous warning. You know, if areas like this continue to pump water, there could be a time when some of those areas run dry. So for the last 10 minutes or so, I've been up here telling you how much water we have here in Nebraska, and we truly are fortunate to have such large quantities of groundwater. But we're certainly not immune to problems and overusing that resource. If we have so much water, why should we care? Why should we spend the resources to monitor groundwater? And there's a number of reasons. First off, resource conservation. Not all parts of the state have the same amount of resources that can be used. State compacts. A few weeks ago, Jasper Fanning was here from the Upper Niobrara, or I'm sorry, the Upper Republican NRD, talking about how we're pumping water back into the Republican River out of the ground to meet compacts and agreements that we've got with our neighboring states. Pumping groundwater, we essentially have reduced the flow of the Republican River, and now we need to augment that. And one that really gets people's ears to perk up is economics. Here in Nebraska, we have a thriving industry in agriculture. Growing this corn, growing the soybeans, making ethanol, producing beef, All this takes water. And if we misuse our resources, this is something that would certainly have a big impact on the state. A more personal level, someday some of you might want to buy a farm. A little knowledge in groundwater and geology can go a long way. If you're looking at a farm down here in Saline County near the town of Crete, you have no problem putting in an irrigation well that may pump 1,200 or more gallons per minute. Have some really great arable land. Move a few miles away down to central Saline County, try and put that same well in, you'll be lucky to get a domestic well for drinking water. Still have good land, but you're not going to have that water. So back in the 1920s, the state legislature put together the Nebraska, or the Conservation and Survey Division, which essentially is a state geological survey. The CSD is tasked and has been tasked with monitoring groundwater since the 1930s. Some of the lines right out of the state legislation. The CSD is to, among many other things, study the water-bearing formations of the state and assist the citizens in locating water supplies, and survey and describe natural resources of the state, including soil, water, water power, potash, forests, roads, materials, and other things. Obviously, this was drawn up back in 1921. Potash really isn't a big resource for the state anymore. So we'll look at these both separately, both monitoring the water as a resource and describing where this water is coming from. And as many of you know, Nebraska has some incredibly varied geology. Here in the eastern part of the state, in the mint green areas, we have glacial sediments, very dense, very clay, very thick tills, which have their own set of problems. As we move to the west, we get more wind deposited sediments. You know, wind-blown dust as loess in some of the gray and tan areas. We have sand dunes, which obviously make up the yellow areas in Nebraska sandhills. When we get out to the panhandle, we have more exposed bedrock. All of these areas have different properties, which allow for different properties for groundwater. How do we learn this? Well, we drill holes. On the right up here is one of our CSD test hole drill rigs. This can drill up to about 500 feet. The other image is a coring machine that we use. This essentially pounds a pipe into the ground and pulls out a relatively undisturbed core of sediment that we can use to describe the subsurface. And we've done this a lot. So since 2006, we've drilled 5,436 wells. As of today, that's probably closer to 6,000. And as you look at this map, it looks like somebody started throwing darts at the wall, trying to place these holes. In reality, these are very carefully placed. Many of these are in lines. Some of these lines have associated cross sections, and we can use this information to make some of these maps, to make some understanding of what's in the subsurface. The process that goes along with drilling these holes, so this is once again our drill rig. This essentially puts a pipe down in the ground with a drill bit on it, spins it in. Mud flows through that pipe, pulls the cuttings up to the surface. Somebody sitting on the back of the drill rig collects those cuttings. Those get laid out and meticulously described by one of our geologists. All those cuttings get a representative sample, which gets put in an envelope. Those envelopes get put in boxes and get stored in the dungeon down in the basement of Nebraska Hall on city campus. And this is a huge resource. So any of those 6,000 holes we've drilled over the last 80 years, I'm doing a study somewhere in the state. We can go down, we can pull those boxes out, we can get those cuttings that came out of that hole, we can get the log sheets and look at these things and do these studies. From this information, we can make maps like this. More importantly, we can make maps describing the aquifers of Nebraska. So from this information, we can describe what parts of the state have aquifers that can conduct a lot of water, that you can support a high capacity irrigation well on, and equally as important, what parts of the state can't support these kind of wells. So moving on to the Nebraska Groundwater Monitoring Program, now we're looking at monitoring and describing water as a resource. The Nebraska Groundwater Monitoring Program began back in 1930. It currently involves 30 different state and federal agencies. Most of those are the Nebraska Natural Resource Districts, who take the bulk of the water level readings every year. Also includes the USGS, the U.S. Department of Reclamation, and a number of others. CSD has produced annual groundwater level change maps, which date back to 1954. Most of those are available online. I'll give you the website for that in a little bit. And we currently produce groundwater level change maps that go from spring of one year to the spring of a following year on various time scales. The data collected over the past 85 years, we've collected more than 750,000 hand measurements from nearly 23,000 wells all over the state. It's a huge database. Many of those wells have long continuous histories of annual measurements. This data is also available free of charge, and it's been used in many studies, both here in Nebraska and all over the country. So in 2014, 4,771 wells were measured to create our change maps. This is actually down a little bit. Normally we get just over 5,000 wells measured. Last year we had a few of our cooperating agencies couldn't go out and do their measurements. In addition to those nearly 5,000 wells, we have 72 wells that take daily measurements. Those measurements then are stored electronically, and we periodically download those measurements. Those would be the red dots on the map. All that data is either available from the CSD or from the USGS. And in reality, there's a lot more daily recorders out there that are owned by the NRDs. There's actually quite a few locations around the state. The blue dots are 58 real-time wells. These take hourly measurements. Those measurements are transmitted through the GO satellite system and are actually updated on the CSD website once an hour. So you can go online and you can see changes in groundwater level readings in near real time. This is kind of what we use for observation wells. The majority of our wells are actually old irrigation wells. Sometimes we're lucky enough to have dedicated observation wells. Sometimes it's sees on the side of the road, essentially a pipe sticking out of the ground with a metal cover on it. This is some of our real-time wells. Has some electronics in a metal case. Electronics take the reading once an hour, and once again it's sent up to the GO satellites, which are something like 22,000 miles up in space. That comes back to the internet and gets posted online. So as I said before, we really do have a vast amount of water here in Nebraska. However, this water, it is limited. It's a resource. And we have seen some fairly significant changes since pre-development. And pre-development would be the time before irrigation was largely, or groundwater was largely used for irrigation in the state. So depending on where you're at, that's somewhere between the 1940s and the 1960s. Some areas of the state, particularly out here in Box Butte or in Perkins, Chase, and Dundee counties, have seen some fairly significant groundwater level declines. Some of these areas have seen declines of nearly 100 feet over the past 70 or 80 years. Other parts of the state, here in the southeast part of the state, have seen some declines of 20 to 30 feet in some areas. We've also seen some significant rises. To the south of the Platte River in central Nebraska, we've seen water level rises of more than 100 feet. Most of that is coming from, from water flowing through unlined irrigation canals for the past 100+ years. All those canals leak. That water filters down into the aquifers and causes groundwater level rises. Similarly to rises associated with some of the irrigation canals in central Nebraska and some of the reservoirs, as well as Lake McConaughey. Some of these areas, particularly in southeast Nebraska, have some incredibly dense areas of irrigation wells. Some of these areas have between 4 and 16 wells per section. That's incredibly dense for this part of the country, which essentially explains why we have some of these groundwater level declines. We look at this on a year-to-year basis from 2013 to 2014, we still see some fairly significant declines. But 2013, we were coming out of the drought. Much of the 2013 growing season was still pretty dry. So particularly down here in the southeast corner of the state, we continue to see some declines in groundwater. Part of that is supplemental water that we needed to grow our crops from the drier conditions. Part of that is continued declines resulting from the drought in 2012. Unfortunately, this is kind of a bad time of year to talk about groundwater level changes. Spring 2013 to spring 2014 water level changes is essentially the latest information I have. I really won't have any new information until the end of next month, beginning of April, when I go out and start to see what water levels did over the winter. At this point, it's a little tough to make a guess. I would guess that water levels probably are going to come up a little bit, but it's hard to say. So if we look at some of the parts of the state, look at some hydrographs, we start to see some patterns that emerge. We'll start off, we have a daily recorder well. It's just outside the city of Seward. And we see this for a hydrograph. So the pre-development value, the value groundwater levels before irrigation was widely used in this area in the early 50s, was about 72 feet, so up in this area. For a number of decades, groundwater was able to be pumped at basically an unrestricted rate. You could use that water for whatever use you liked. And groundwater levels continued to decline from that 72-foot mark down to just under 85 feet. About 1981, groundwater levels really kind of reached a low point for the eastern part of the state. Following 1981, we had a number of relatively wet years. We had some restrictions, some legislation put into place limiting the amount of groundwater that could be pumped, limiting the number of new wells that could be installed. Some new technology was used, reducing and making our water use more efficient. And groundwater levels really continued to kind of climb back to near those pre-development levels. In the early 2000s, much of Nebraska began to experience drought again and needed more and more groundwater to grow our crops. Water levels declined until about 2009. After 2009, 2010, 2011 were two of the wettest years on record for the state of Nebraska. Groundwater levels, at least in eastern Nebraska, some areas began to rise rapidly again, back up to those higher levels, near pre-development. And then the drought of 2012, 1 year decline for this site was 10.83 feet. That almost 11-foot decline was the largest water level decline for this site over the past almost 60 years. That 1 year, we saw declines at this site that was 2/3 the total amount of decline we saw in the the drought in the early 2000s. Water level readings were really dominated by a large drawdown during 2012. There's very little moisture left in the soil and left in the sediment between the surface and the top of the aquifer. Very little water left to go back and recharge that aquifer. So we're continuing to see some, just zoomed in a little bit on this upper graph, continuing to see some rebounds that aren't as high as they used to be, aren't as high as we'd like to see them. So hopefully we'll get another couple of wet years here, and this area, water levels can start to return back to where they were just a few years ago. Look at a little different part of the state out in Box Butte County. This is the Alliance Recorder. This area, hydrographs for this area are very similar to what you would see down in the southwest part of the state. We see this almost linear decline. If you do the math on this, it comes out to average of just over 1 foot of decline per year. In 2012, due to the drought, so from the 2012 to 2013, this site saw just over 3 feet of decline, which for this area isn't necessarily unprecedented. It's not good, but it's not unprecedented. And since then, water levels are continuing to decline at this site. This is actually one of our real-time sites, so this is updated as of just a few days ago. It remains to be seen. Hopefully we can get a couple wet years out here and get water to at least level out a little bit. But essentially we're pulling water up from very deep. The aquifers in this area have little connection to surface water. They're very difficult to recharge, and these areas don't get much rainfall. They get significantly less precipitation in the western part of the state than we do here, so there's very little water to recharge out here. So like I said before, 1981 for the eastern half of the state, water levels kind of reached a low. This is when some regulations were put into place, try and correct some of these declines. By 1981, this area in the southeast part of the state saw declines of mostly in that 5 to 20 foot range. 1981 to 2014, if I was to put this map up, say from 2011, much of the southeast part of the state had quite a bit more green in it. Water levels had come back up in some areas down in this part of the state. Recently, with the drought, with the increased need for irrigation over the last few years, many of those rises since 1981 have gone back to approximately the 1981 levels, or even declined a little bit. However, if we get a couple more wet years, have a decade or so of near average precipitation, I see this area of the state coming back up, maybe not necessarily to pre-development levels, but I think we'll eventually see some rises. Some other parts of the state, up in the northeast part of the state, have also seen some rises since those lows in 1981. Again, out in the western part of the state, the Panhandle, southwest corner, we continue to see those linear declines. We'll talk a little bit about the drought. So, some 2012 statistics. Statewide precipitation averaged 10.34 feet below normal. 2012 was the hottest and driest year on record for the state. However, comparatively, if we compare that to what Nebraska and the Plains experienced during the Dust Bowl, that was really just a drop in the bucket. We had a year and a half of extremely dry weather that persisted for many years. Our conservation practices are much better, keeping the land from blowing. We have irrigation. We can keep vegetation green on the surface. It may not be great crops, but it helps keep things from the land from degrading. What really made the 2012 drought detrimental to Nebraska were a couple factors. Starting in early early 2012, going back to March, temperatures were extremely warm. So we had temperatures in March that were 6 to 15 degrees above average. Thinking back to 2012, I had tomatoes planted in my garden the first week of April. This was an incredibly hot year, so it caused vegetation to green up much earlier than normal. So we had trees that were beginning to leaf out in late March. Vegetation was greening up. It was pulling up moisture out of the soil. It was sucking up all our soil moisture. And at the same time, we had very little precipitation. Same month, March was well below normal on precipitation values. We had very little rain to replace the soil moisture that was being pulled up by those early onset of the vegetation greening up, and this caused some problems. And on both these maps, April, May, June, all got worse from this point on. So following the dryness that we had in March, the farmers go to plant their fields. They need to irrigate to get their seeds to sprout, get their crops to grow, and it really starts to put a strain on groundwater resources early in the year. The drought reaches basically its peak in October of 2012, with 98% of the state ranked by the U.S. Drought Monitor as either extreme or exceptional drought. Those ratings basically exceptional drought being exceptional and widespread crop pasture losses, shortages of water in water reservoirs, streams, and wells creating water emergencies, and extreme drought being major crop and pasture losses, widespread shortages in water and water restrictions. So the drought really persisted into early 2013. Conditions were really pretty dry over the 2013 growing season, not nearly as severe as they were in 2012, but that caused some of those continued groundwater level declines we saw earlier. As we come into 2015, as ranked by the U.S. Drought Monitor, most of the state is really out of drought. Only some small areas that are classified as abnormally dry. So precipitation, once again, 2012 to 2013, every weather station that we record in the state registered below normal. Some of them only registered 30% of their long-term average for precipitation. Once again, we were fortunate that 2010 and 2011 were almost record wet years. If we look at the 10-year long-term precipitation map for the state, even following the drought that we experienced in the early 2000s, some of the weather stations still experienced a surplus of precipitation. Over the long term, some of those weather stations were experiencing 120 to 130% of their normal. Following the drought of 2012, we essentially erased that surplus, that extra moisture at some of those sites. And it essentially brought the state down to near average over the long term on precipitation. As far as groundwater was concerned, in 2012, from 2012 to 2013, the hardest hit areas was northern Colfax County, which recorded groundwater level declines near 25 feet. Parts of Saunders and Butler counties also saw declines in that 20-foot range. Both those areas had some problems with wells going dry and such. On average, if you were to take all the water level changes from all 5,000 wells, Nebraska saw, on average, 2.55 feet of decline in wells throughout the state. The only counties in Nebraska that didn't experience groundwater level declines were Grant, Hooker, and Thomas counties, all of which are in the Sandhills. Think back to that map I showed you of saturated thickness. These areas have nearly 1,000 feet of saturated thickness, some really huge amounts of water, and it takes quite a bit for these areas to show a loss. It takes a little bit for the lack of precipitation to move its way through this area. So we didn't see really any declines in those three counties. We might see them in upcoming years, but they managed to get away relatively unscathed. Following 2012, once again, 2013 was a relatively dry year. We saw some more water level declines, particularly in the southeast part of the state here. Like I said before, some of those were a result of pumping additional groundwater to grow our crops in the drier conditions. Part of that was the continued dry conditions, still the effects of that still making their way through the aquifer, having those declines show up. Some of the hardest hit areas, once again, Colfax County, actually saw some rises in that 2 to 5 foot range. Hopefully we'll get another couple wet years and those will come back up a little more. And the western part of the state actually fared a little bit better last year. So some resources. Go.unl.edu/groundwater. SNR and CSD have a wealth of groundwater information on this page. All the 23,000 wells we have in our database, all the measurements are available at this link. Our real-time network information is available here. All of our water level change maps going back to the 1950s are available online, as is the accompanying water level reports. These are also available at the Maps and More store at the front desk out in the lobby. We're currently working on our real-time groundwater level site. We're trying to upgrade it, make it a little bit more user-friendly. This is what we're aiming for. Hopefully we'll have this up and running next month sometime. All 58 sites around the state have an icon. Those icons are ranked every hour, and they have a color-coded value. So sites in the state that are red are at 0 to 20% of their normal. Sites in yellow are near their average water level. Sites in blue are well above their average level. This was actually accurate as to last week sometime, so you can get a general idea of what's going on around the state right now. So hopefully we'll have this up and running in a few weeks. Another great resource is the Groundwater Atlas in Nebraska. I believe it's $15 at the front desk. Basically everything you want to know about water in Nebraska is included in this book. And if you're looking for information on water regulation, the Nebraska Natural Resource Districts is a great place to go. Their website is available here. And with that, if you have any questions, I'd be happy to answer them.
Aaron, thanks for your talk. I think it was fantastic to look into what's the state and the changes in groundwater in our state. My question, or I have two questions. The first one is, to what extent we can, based on the observations, attribute that the groundwater might be subsidizing somehow the agricultural activity in the state? And this question is basically based on the responses or the pulses in the groundwater level responses that you track. And the second question is, how do you see your activity evolving in the future? This could be in terms of drilling more wells, using more information technologies, or what would be the next step?
Well, to answer your first question, it's a little bit hard to, I'm assuming you're asking, it's difficult to subsidize, say, in a dry year when some of the cycles are showing some groundwater level declines for part of the state. I don't know that there would be the funding out there to change some of these things, or for that matter, in the western part of the state, we're growing corn in areas where we get 10 inches of precipitation a year, and most of the water that's required to grow these crops has to come from the ground. Eventually those are questions that we as a society are going to have to ask. Is it worth it to be growing, corn in this part of the state? When water levels start to decline to the point that we can't support this anymore, we're going to have to come up with some answers, some other things to do. As far as where we are going in the future, many of the Nebraska natural resource districts continue to expand the number of wells they measure every year. We're trying to locate areas that are potential problems, try to monitor those areas more closely. We're also trying to use things such as our real-time network. Some of the areas of the state that are problematic, if we can go online and get an up-to-the-hour reading on what groundwater levels are doing in that part of the state, if hopefully in the future with more funding and more personnel time, we can expand those networks as well.
Okay, so just a couple quick questions. First, you said there were 3 counties that didn't experience change in that 2012 drought. You said Grant, Hooker. What was the other one?
Grant, Hooker, and Thomas.
Thomas. Okay, and you also said that on average in that drought there was about a 2.5 feet decline in water levels. Are there any numbers as to averages and increases in? Because you said there was like a slow increase in 13 and 14, but not where you want it.
Right.
Is there any average numbers right now as far as the increase in 13 and 14?
Yes. From 2013 to 2014, the average decline across the state was 0.5 a foot, 0.50.
So it still declined between 13 and 14?
It did still decline between 13 and 14, yes.
All right, cool.
I was just wondering about the structure of the wells, and can you tell us a little bit about where they're screened? Are they screened completely through the thickness of the aquifers, or are they at discrete depths and therefore sensing maybe a pressure head instead of a water table elevation? And just help us understand a little bit about that.
Sure. Kind of all of the above. So depends where you're at in the state. Generally, the wells are designed to be screened in the most productive part of the aquifer. Some areas actually have what are called nested wells, so there will be multiple screened areas in a series of wells. So there may be a deep aquifer that has a screened interval in that deep aquifer. There might be another aquifer on top of that that's separated by a impermeable layer. There may be a well right next to that, measuring that one as well. In some areas, yes, they're confined aquifers. So essentially, yeah, you're measuring a pressure head or a potentiometric surface rather than the actual elevation of the water table. So it kind of depends where you're at in the state and the conditions of the aquifer at that location. Making statewide maps like this, that's one of the challenges, is when you get to those boundaries, how do you best represent that? And we do our best to make those representations, but on a statewide map, it's about the best you can do. So does that answer your question?
Okay, well, let's give Aaron another hand, and thank you very much.